Hello everyone, this is Kaveri from Tribly branch. My roll number is 2195 Aeronautical Institute of Aeronautical Engineering. My topic name is high voltage challenges of implementing higher frequency magnetic sine wide band gap converters. Introduction, overview of wide band gap converters, importance of high frequency magnetic components, applications, power electronics, renewable energy, electric vehicles, aerospace. So power electronics, renewable energies or the wide band gap converters, importance of high band frequency. Why higher frequency? Advantages we have. So advantages are reduced size of passive components like inductors, transformers, higher power density, faster transient response. Challenges, increased switching losses, complex thermal management. Challenges in magnetic component designs are core material selections, ferrite, nanocrystalline, amorphous, electric current losses in high frequency operations, mysterious losses and their mitigations, saturations issues in high power applications. So the core material selections, eddy current losses in high frequency operations, mysterious losses and their mitigations, saturation issues in high power applications. So thermal management challenges. These challenges were increased power dissipations at high frequency, need for advanced cooling techniques, liquid cooling, heat sinks. So material constraints affecting heat dissipations, control and stability issues, control design complexity at high frequencies, resonance issues in magnetic components, need for advanced digital control techniques. So are the stability issues for the resonance issues in magnetic components and need for advanced digital control techniques. The increased power dissipations at high frequencies. So these are control stability issues, control design complexity at high frequencies, resonance issues in magnetic components, need for advanced digital control techniques. Manufacturing cost challenges, high cost of wide band gap materials like silicon, difficulty in manufacturing custom high frequency magnetic components, lack of standardizations in high frequency designs. Potential solutions, improved core materials to reduce losses, better cooling strategies. Manufacturing and cost challenges are the high cost of wide band gap materials, difficulties in manufacturing custom high frequency magnetic components. So there are some bullet points in switching losses. Higher frequencies lead to increased switching losses in WBG devices and like electromagnetic interferences. Faster switching speeds generate more EMI, requiring careful mitigation techniques. Thermal management or higher frequencies result in increased heat generation, demanding efficient cooling solutions. Gate drive design, WBG devices require specialized gate drivers with fast switching capabilities. layout and packaging, high frequency operations. Next, next states optimized PCB layout and device packaging to minimize parasitic effects. WPG devices specific challenges. Bullet points are their cost. We have WPG devices are currently more expensive than silicon counterparts. Reliability. Long-term reliability of WBG devices under high frequency stress needs further investigations. Packaging. Suitable high frequency packaging for WBG devices is still an area of development. So availability. The supply chain for WBG devices is not as mature as for silicon devices. WPG device specific changes and switching losses. We have electromagnetic interference, faster switching speeds generate more EMI, thermal management, and higher frequencies result in increased heat generation. And the gate drive design. WPG devices require specialized gate drivers with fast switching capabilities, layout, and packaging, high frequency operations, which we manufactured, and cost challenges are high cost of with band gap materials and difficulties in manufacturing custom high frequency magnetic components. So lack of standardizations in high frequency designs and potential solutions. Improve core materials to reduce losses, better cooling strategies. Control and stability issues for controlling design complexity at high frequencies. Resonance issues in magnetic components to need for advanced digital control techniques. So the thermal management challenges, increased power dissipations at high frequency, need for advanced cooling techniques, liquid cooling, heat sinks, material constraints affecting heat dissipations. Controlling stability issues are control design complexity at high frequencies, resonance issues in magnetic components, need for advanced digital control techniques, challenging in magnetic component designs, core material selections, eddy current losses in high frequency operations, hysteresis losses and their mitigations, saturation issues in high power applications. Advantages, which are reduced size of passive components, indicate inductors in transformers, high power density, faster transient response. Challenges and increased switching losses, complexity, thermal management. Thermal management challenges, increased power dissipations, and high frequency need for advanced cooling techniques. High cost of wide bandgap materials, difficulties in manufacturing custom high frequency magnetic components, lack of standardizations in high frequency designs and potential solutions. And these are bullet points, and coming to the wide beyond of specific challenges. In conclusion, we can summarize the key challenges of implementing higher frequency magnetic sine wide band gap converters, highlight the potential benefits and future directions of this technology, emphasizes the need for continued research and development in this area. So these are the conclusions which we summarize the different challenges of implementing high frequency magnetic sine wide band gap converters.